because it's 2. Or multiply. Divide. Do we have to multiply them together? On number 16, it had all its numbers, but this and its answer, it has it
No,
multiplied
that's
together.
okay. That's okay. As long as you understand, yeah.
Okay. I want to see.
I got what you got.
We got 25 wrong.
But everything else right.
Yeah, we got number 25 wrong. I don't know. Since it doesn't show work, I don't know what I did wrong either.
Okay, so how would you simplify just the first part?
I
guess it'd be log of 2x divided by y squared, right? Minus the log of 3 over 5 squared.
I had 3 times.
Yeah, I thought it would be 10.
Oh, sorry, yeah, it's plus.
I was like, what?
My bad. Okay, so then if these logs are subtracting, then it's the log of this divided by this. So that would be 4x squared over y squared over 75. And so that would be 4x squared over 75 y. The log of that, obviously.
So basically, I just didn't finish the problem. I don't know.
I did mine out.
I just has lots of different colors. So these are just separate. Right. That's weird.
Okay. Alright.
Wear good snowshoes today.
Okay. There's those, if you would. All done? One more. Okay. Let's do some examples of that. Do you guys remember what that means? We haven't done a lot of derivatives lately. So like, this means if you have something to an exponent, then you write the same thing again, then you write the natural log of whatever the a part is, and this means then you take the derivative of the u part, and that multiplies on. You know, because if you don't know what the formulas mean, then that's going to be a problem, right? So then this means you take the derivative of the u part. So with this, you have the natural log of a u, you put 1 over the u, and then this means you take the derivative of the u and multiply that afterwards. Right? Okay. Okay, same thing with this. Okay, let's just do some and we'll see how you do. So find dy dx of y equals e to the x plus x squared. So if you look at the e to the x, derivative of e to the x, we just repeat the e to the x part again. And then after that we have to take the derivative of whatever the exponent is and multiply it. So this is just going to be the same again, e to the x plus x squared. And then we'll multiply by the derivative of x plus x squared, which would be what? Right. And that will be your answer. They're actually not, they're not bad.
So we were using the derivative of EX equation?
Yes.
Okay.
Y equals 2 to the x minus 3. So for that one you have to use first one. Yep. So it's going to be what?
2x minus 3.
The minus 3 here is separate. So like remember we take the derivative of each part. So the derivative of the minus 3 is going to be 0, so we don't have to worry about that. So really we're just taking the derivative of 2 to the x.
So 2x ln
2 to the x times what?
ln 2.
Yes, ln of 2.
Times.
That's it.
So we don't have to do the derivative at the end?
Well, I guess we do. But it's 1. So it's not going to matter.
Okay.
But yes, we should do that. So times the derivative of x, which is 1, so it will still be 2 to the x times ln of 2. So you don't forget. Alright, y equals the natural log of x squared. There's two ways we could do this. One way would involve leaving it, well, one way would be just to leave it as it is and do it. And the other way would be to rewrite it using the properties of logarithms that we learned yesterday, which I think would be the easier method, but you could do it either way. What was the properties of logarithms? You said it was
2 ln x.
Yes, we could rewrite that as 2 ln x, and then just do 2 times the derivative of the ln of x instead of trying to find the ln of x squared. So it would be 2 times,
So then what equation
the natural log one. This one.
Oh.
So 2 times what?
Would be 1 over x.
Right. Times the derivative of x, which would just be 1. So that would be 2 over x. Would you like to see how to do it the other way, or are you good? Confusing?
This way makes sense.
Yeah. Alright, good. One more then. Y equals log base 2 of 1 over x. And again, we could leave it as it is, or we could rewrite that using the properties of logs that we did yesterday, which again would be the easier way to do it. So how would you rewrite that one?
log is 2 1 minus log is 2x.
Yes. So we're gonna have to find the derivative of both of them separately, but in the end it's gonna be easier than doing it the other way, in my opinion, so I could show you if you wanted. So we'll first find the derivative of the log base 2 of 1, and then we'll find the derivative of the log base 2 of x. So what would be the derivative of log base 2 of 1?
1 over
1 over what?
ln of 2
Mm-hmm. Times. Yes, so really the log base 2 of 1 is a constant, right? Because there's no variables there. It's not like a nice number that we like know what the value is, but it's a constant. So if you recognize that immediately, you can know that the derivative of a constant will be 0. But if you don't, then you can see here, once we take the derivative of 2, we find out that all of that's going to be 0, so that will drop out. Okay? And then we find the log base 2 of x, so we'll have a minus there in front of it. And what will be the log base 2 of x?
1 over ln 2.
5x.
Times,
What?
wait a minute. One over u ln So it'll be 1 over, what's the u part? X, yeah. So 1 over x ln of 2. Times 1. So the derivative of that is going to be negative 1 over x times the natural log of 2.
Okay.
You don't seem so sure.
I'm kind of confused, but like I understand it, but at the same time I don't.
Is there anything I can clarify? More practice? Do you want to do some of these together? Or do you want to try to do them on your own first? Where are we at?
I can
Try.
and see, and then
Okay.
ask if I don't.
Okay.
I think the 2's the A. No, wait. 2, we just dropped the 2. I think. E to the x times ln of 2.
Okay. I'm looking at this one.
Me too. What about that? Oh no.
I'm looking at this
top
one.
I'm looking at this one. Oh, what's the difference?
This one has an E in it.
What's the difference between the derivative of a to the x or e to the x?
A is like a regular number, where E is the natural number E.
Okay, never mind. So I have to use that.
So this
So
is
just-
just the X.
8. Do we have to do anything with the 2?
No, yeah, okay.
For number 1,
Yeah.
Yeah.
2 e to the x. It would just be 2 multiplied by the derivative of e to the x. You know, like the constant multiple. If there's ever a constant in the front, you just multiply the derivative of that times the constant.
So is it 2 in the x?
Yep.
Okay.
So this one we have to bring it to the bottom.
No.
We do.
Do it? Can we just leave it as a negative exponent or do we have to fix it?
You can leave it.
Okay.
Awesome.
So e to the negative x
Does that mean it's
times
negative E to the negative X?
Because
Yes.
the derivative.
Ooh.